Hi guys, welcome to this set of videos. Remember, what we're doing here in this chapter is we're looking at ways to solve non-right triangles, meaning triangles that don't have a right angle in them. Previously, we used the trig function sine, cosine, and tangent to help us solve for unknown measures in right triangles. But now we're looking at an expanded case where we're including all possible triangles, meaning triangles that don't have a 90-degree angle. And what we found is the trig function sine, cosine, and tangent will not work if it doesn't have a 90-degree angle. So, in the last set of videos, we took a look at the law of sines, which allows us to solve for unknown measures in a non-right triangle. And now we're going to take a look at the law of cosines. And you may be thinking to yourself, well, if I already have the law of sines, why do I need the law of cosines? That is a fantastic question, and I'll start by explaining that. But first, our essential question. What is the law of cosines, and how can we use it to solve for unknown measures in non-right triangles? The way we'll do that is by introducing you to the law of cosines. First, what is the law of cosines? Then we'll show you how to use the law of cosines to solve triangles. So now back to my previous question. If I have the law of sines, which allows me to solve for non-right triangles, why do I need the law of cosines? Why can't I just use the law of sines? And that is actually a really good question, and one that I'd like to show you right down here. Remember, when we did the law of sines in the previous section, we talked about the information that you need to be given in order to use the law of sines. In order to use the law of sines, there were three sort of cases where you could use the law of sines, or the law of sines would be useful in helping you solve that triangle. It was if you were given an angle, a side, and an angle, if you were given an angle, and a non-included side, and then a side angle. And it was these three cases where the law of sines applied. Now, please keep in mind that this was the ambiguous case. Meaning we had to check it. If you were given the information about the side, and angle of a triangle, you had to first find the height and then compare the height to the two sides that you were given to find out if there was a possibility of maybe there being two triangles that you may have to solve. It could or it could not. It may just be a regular, like all the other problems where there's just one possibility, but this did lead to the potential of it being the ambiguous case where there were two different triangles and you would have to solve them both. But now here's the thing, right? Remember our list, right? Our list for the triangle congruence theorems, right? So the triangle Now, again, we're not proving triangle congruence here. That's not what we're doing. We're not proving that triangles are congruent. We're trying to solve non-right triangles. But the point is this. Remember, our list was side, angle, side, angle, side, angle, 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 side, and side, side. Well, what we've now seen, right, is that two of them apply to the law of sines, right? Angle, I'm sorry. Yeah, angle, side, angle. This one goes with the law of sines. Angle, side, angle. There it is, angle, side, angle. If you're given that information, law of sines works. Angle, angle, side. Angle, angle, side. Also goes with the law of sines. Law of sines. But you're left with two, side, angle, side, and side, side. What if you're given these pieces of information? Right? The law of sines will not work if you're given side, angle, side, or side, side. Right? These are the only three that work for the law of sines, and this one's the ambiguous case. You may have to work a little bit harder, but the law of sines will still get you there. Anyway, the point is this. Given this information, the law of sines will work. The law of sines will not work for these two cases, side, angle, side, or side, side. And that's where the law of cosines comes in. if you are given side, angle, side, or side, 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 the law of sines is going to be the one that you'll need to use in order to solve that triangle. So let's take a look at what the law of sines is, and I've got them for you right here. Now, when it comes to the law of sines, all right, I recognize that there are 3 different formulas written here. It is not that complicated, I promise you. In fact, actually, the one that we're going to use doesn't matter what the problem is that you're given. This one will always work, right? This is the one that will always work. We can adapt any problem to fit this particular formula. Any problem can be adapted. Adapted. I would 2 T's in it. I'm going to say that there isn't. Adapted to fit this case right here. So while there are 3 different formulas, and technically, yes, depending on the information you're given, you should use, but what we'll do is when we get to the problem, and I'll show you, we're just going to rename stuff. We're just going to rename it, which you certainly can do, so that this is the one that always works. And that'll just make it a little bit easier to work with and to remember. Not that I'm going to ask you to remember it. I will give you this formula, the law of cosines, if you're taking this class with me. But if you have a geometry teacher that would make you memorize the law of cosines, I'll show you how. You don't have to memorize all 3. You just have to remember this one, and you'll simply change a few things in the problem that you're given to make it work. So with that in mind, this being the law of cosines, we'll go ahead and take a look at some problems on the next page of the notes, and I'll show you how the law of cosines works. I'll meet you there.